Okay, next question here. Determine if a number is prime. Write a function that takes an integer and returns true if the number is prime and false otherwise. So prime numbers are numbers that are only divisible by themselves and one. You got a couple of special cases like two and things like that, but let's just do the catch-all. Itself and one. So it's going to be called is prime. It's going to return true if it's a prime number and false otherwise. So its return is going to be Boolean. We'll call it is prime. It's going to take an int as a parameter. We'll call that guy int n. So we prototyped it. Let's go and write it now. All right, so we know the number is going to be evenly divisible by 1. We know the number will be evenly divisible by itself. So we need to check the numbers in between. So we're going to check all the numbers between 2 and n minus 1. If we find anything in there that evenly divides it, we know we're not dealing with a prime number. So we'll create a loop here. For int I is equal to 2. I is less than or equal to, well, we can say I is less than n. That'll work. And then I plus plus. So we're only going to go up to n minus 1. So we're going to check all the numbers between 2 and n minus 1. And each time through, we want to find out, is n evenly divisible by that number? Now, there are certainly optimizations you can do with this. And once you get more than halfway there, you technically only actually need to check up to the square root of n. But we'll just brute force this. This makes logical sense. So we're going to check every single number between 2 and n minus 1. If the current number we're looking at, when we divide n by that number, so n mod I, if that's equal to 0, if when we take n and divide it by I, we get a remainder of 0, that means we have discovered another number that evenly divides n, therefore it is not prime. So we will return false. All right, so if n is evenly divisible by the number we're currently interested in, that's what this if statement says right here, we'll return false. Remember, return makes a function immediately end, so we're not going to check any other number. It doesn't matter if 20 different values return evenly divided n. As soon as we find the very first one that breaks the prime rule, we'll go ahead and return false. After the for loop, if we're still kicking, we know this guy only had was only evenly divisible by 1 and itself because we checked every other number between those. So we'll go ahead and return true. This is a prime number. All right, so we'll go ahead and test this now inside of main. So we'll call is prime. Let's call it on an 11. So an 11 is a prime number. Now, as we have it right now, since all programs begin and end with main, I'm calling the function, but I'm not doing anything with the result. So if I run this program right now, I'm going to get no output. I can go ahead and output the answer directly. So there's my 1 for true. If we were dealing with newer languages like Java and C#, you'd actually get the value true. With an older language like C++, it's a 0 and a 1. 1 is true, technically not 1. Actually, it's the other way around. 0 is false. Anything but 0 is true. Typically, it's a positive 1. So in this case, 11 is prime, so we got a 1. Let's go ahead and just do so we'll go ahead and say bool answer is equal to is prime. And let's pass this guy a 6. 6 is not a prime number. There are other numbers that evenly divide 6 besides 1 and 6, for instance, 2 and 3. So we should get a false out of this one. We'll go ahead and output the answer. And there is our 0 for false. All right. So there's something that checks for primes. A couple of things to focus on here is as n gets really, really, really big, this particular program might slow down because you are checking, let's say n is a billion. You are checking every single number between 2 and 999,999,999. That's a lot of numbers that you're technically checking. So that's where optimizing it some could be handy. All right, so there's an example of is prime.